Okay, hi Year 11. So in this video, I'm going to show you exactly where to put a line of best fit, and you can get your calculator to do it for you. So let's say we've got some data on some test scores, okay? So some percentage scores from a maths test and some percentage scores from a science test. And, you know, what I've done there, just very roughly, I've plotted those on a scatter graph. So if someone scored 38, the science score was 42. If someone scored 92 on maths, they scored 96 in science. And we're generally seeing quite a strong positive correlation here. If you're good at maths, you're probably good at science as well. Okay. So rather than sort of guessing exactly where that line of best fit should it be like this? Should it be like that? We can get the calculator to tell us, okay? So we're going to go to statistics, okay, and make sure, again, you clear all data that's already there, because it will muck everything up if you've got data from a previous question. So put in list 1, put all your math scores: 38, 92, 84, 97, 78, 15, 49. We've got 7 students that took these two tests, okay? Make sure then that you pair off the corresponding science scores in list 2. So 42, 96, 83, 74, 69, 27, and 59. Okay, so what we can do is we could do something called a linear regression. A linear regression. Linear regression simply means tell me what the line of best fit for this data should be. Hang on, let's get out of there. Oh, what do I want to do? I want to go back. Exit. Why can't I go back? Oh, let's go back there. Right. I'm going to go to F2 for calculate, okay? And then I'm going to push this button here, F3, because that REG stands for regression. So it's saying, please perform a regression, okay? And this is a linear regression. We want to know what the line of best fit is. So we're going to go for F1 for x. F3, x squared would tell me, give me a quadratic, okay? And F4 would say, give me the best cubic. We're going to keep it simple. All we want is to know what's the straight line that makes sense here. So we're going for F1, okay? Then just pick AX plus B, okay? And it will give you the values, okay? It will give you the values. So what it's saying is, the line of best fit that needs to go here is y equals A is 0.717 to 3 significant figures. So 0.717 x plus 17.9 for your y. Okay. So what that really means is that if you know the math score, what you're going to do is do 0.717 times the math score plus 17.9, and that will give you a prediction for what that student's science score would be. Won't be perfect. The stronger the correlation, the better the prediction. This little number here, R, this tells me how strong the correlation is. If it's a perfect correlation, R will be equal to 1. If it's a perfect positive correlation, it will be equal to 1. If it's negative 1, then it's a perfectly strong negative correlation. The closer that value is to 0, either negative or positive, the weaker the correlation. So this value of 0.935 is telling me that the correlation is very strong. So any prediction I make from a student when I know their math scores to find out what their science scores is going to be fairly reliable. It's going to be a pretty good estimate. Okay, so that's that. Let me know if anything you don't understand.